All right, Jeffrey, you got something for me there?
You got x equals 0.4771.
No. I don't know. Sarah, you got something for me?
No. What do we do with the negative one?
Okay, what do we do at the very beginning is the question we need to ask.
We're just gonna multiply log x. We're gonna get log x and negative log 1. And then what do we do with negative 1?
Okay, I don't understand the first thing you said. What was the first thing
We're gonna
you said?
multiply the log with the x. And
Okay,
negative
I am
1.
not going to multiply anything.
Really?
No. There's no multiplication in here. I'm not multiplying anything right here. Okay? I'm taking the logarithm of 3. I'm taking the logarithm of x minus 1. And then I'm subtracting them. Okay, so this is a logarithm problem. When I said, if you have the variable in the exponent, then you need to take the logarithm of both sides.
Yes.
But if I have the variable in the logarithm, what do I have to do?
Separate it.
No. If I have the variable in the exponent, I take the logarithm. If I have the variable in the logarithm, I have to do the exponent.
Yeah.
But it's not always e.
Oh.
I have to use exponents. I have to retranslate this so that it's in terms of exponents, not logarithms. Okay? What if I said the logarithm of x is equal to 2? What would you tell me? Sarah, can you tell me how to write this using exponents?
Log 10 to the power 2. So I can find x.
It's not log 10 to the power of 2. Okay? This is log base 10.
Uh-huh.
Okay? How am I going to rewrite this using exponents?
10 to the power of 2 equals to x.
10 to the power of 2 is equal to x.
Okay.
X is 100.
Yeah.
How do I rewrite this? I use the definition of logarithms and I rewrite it. Okay? That's what I need to do with this problem. I need to rewrite this problem using the definitions of logarithms. In order to do that, I have to have the logarithm on just one side. So I'm going to get this so that the logarithm is just on one side. Jeffrey, what would you recommend in order to get the logarithm just one side?
So if we rewrote that, it would be 3 to the.
We are not going to rewrite it first.
We're not gonna
The
rewrite
first
it
thing we're going to do is to get the logarithm all to one side. I want everything that has logarithms to be on one side of this.
We would minus the log of x minus 1.
I would. So I'm going to rewrite this as the logarithm base 10 of 3 minus the logarithm base 10 of x minus 1. And what do I have on the right side?
Negative 1.
Negative 1. So now I want to combine this so I only have one logarithm. What does that look like?
It'd be the log of 3 times x minus 1.
It is not. This is a subtraction symbol.
Divide.
I'm going to divide. So what is that?
Log 3 divided to
X minus 1.
log x minus 1.
Okay. I am combining logarithms. I want to combine it into one logarithm.
Gonna be
I do not divide the logarithms. I do not say logarithm divided by logarithm. Jeffrey, what am I supposed to say here?
The logarithm of 3 over x minus 1.
3 over x minus 1. I do not say logarithm of 3 divided by a logarithm of x minus 1. It is one logarithm of this, right? Okay, what's on the other side?
Minus 1.
Okay? Now I have all the logarithm things on one side of the equation. How am I going to rewrite this using exponents?
So it'd be 10 to the -1 equals 3 over x minus 1.
Okay, what's 10 to the -1 power?
Oh, that would be 1/10.
1 over 10 is equal to 3 over x minus 1. How do I solve for x?
You would need a common denominator between both, so you multiply 10 times x minus 1.
Or, since I have one fraction on one side and one fraction on the other, I can cross multiply or multiply diagonally.
30 is going to equal to x minus 1.
30 is equal to x minus 1. What's x equal to?
30 plus 31.
31.
So how did you get into that first?
Okay, this I'm going to rewrite using exponents. It has a base of 10.
Oh.
The exponent is -1.
Yep.
All right, well, I think we need to do another one of these. That might work. Huh. I'm not sure. I don't know if I like that. I'll try it. Because chapter test. I suppose that. Oh. Yeah, that should work. So I start typing this onto the website to see if I can get it to work. And it comes up with this equation as a default. Kooky.
They are watching and listening.
Uh,
No, no one believes me.
I believe you.
It's true.
I should tell you my story.
Does your phone sometimes
I had just woken up and I was lying in bed and I was just checking my phone and there was a story about controlling the outlets by your voice so that you can say, you know, okay, Google, turn the lights on. And it'll turn on the lights because you don't have to have your whole house wired in a different way. You just have to have the outlet that can respond to your voice. Okay? And so I said that to my wife. I said, you know, it's possible you can say, okay, Google, turn on the lights. And my phone said to me, I'm not set up to do that.
Yeah.
I was like, what?
Yeah.
I did not know that my phone was automatically recording everything.
Well,
It's
you have to
responsible
say,
so many times.
you have to invoke it to say the
Okay, Google.
okay Google part. Then it starts to listen.
No.
No, because sometimes I'll be talking about something and go to Google it and it immediately brings out a suggestion. And be like, whoa.
So you weren't saying okay Google?
No.
I said, okay, Google,
Yeah, that's when
would
it
turn on
started.
my lights.
Well, I
And
guess
it
it's always listening
responded.
for you to hear.
It has to always listen to me in order to know that I'm going to say, okay,
Exactly.
Google.
Yeah.
Or else, how would it know? It has to be constantly listening to me all the time.
True.
And when I say, I don't want you to listen to me, that doesn't mean they have to.
Mhm.
It means they should, but they don't have to.
It's weird. It's creepy.
It is, but it's a world we live in right now. Oh, I should have done this other way around. Oh, well. Well. All right. Sarah, what should we do with this?
From my understanding, since we're adding, we're gonna multiply both of them.
Okay, so what do we get?
It's gonna be x squared minus 6x, no, sorry, x squared minus 5x minus 6, which is gonna give me a positive x plus 1 and x minus 6. Which is
No, that's not what we do.
Really?
Okay, we have this.
Okay, and then we have the 3. Then the 2 is gonna be the power of 3,
It is.
and then it's gonna give me an
So-
8 that way.
It is. So I have x squared minus 5x minus 6 is equal to 8.
Yeah,
How do I solve that problem?
when will we factor it out first?
We are not going to factor it.
Oh, we're gonna bring it to the next side before we factor it. So it's gonna be x squared minus 5x plus 2.
Nope.
Oh,
Subtract 8.
minus, what's that, 14?
It is.
No, all the factors are nothing.
No.
Okay.
The only time you would factor this is if you're completing the square, and then you have to add the 6 to those sides. I would not recommend that.
Okay, so now 14 and 5. That's gonna be,
Jeffrey, what's the, how's
9.
that factor?
I didn't get that far.
Okay. I want to factor 14
5,
with a negative sign so that I get a negative
2
sign.
and
2 and
7.
7.
2 and 7,
Yeah,
and the 7
it's
will be
gonna be
negative.
negative and positive 2.
So then what are my answers?
X is gonna be negative 2 and positive 7. Maybe.
I fell into the same trap she did.
No.
However, this is not correct yet.
Oh,
No.
now we gotta plug it back in to make sure that
We have to check and make sure these numbers work. If I put in a negative 2 up here,
you get a negative
I would get a
1.
negative in my logarithm, and I cannot take the logarithm of numbers. So this does not work. X is equal to 0.
How do you know it didn't work?
When I put a negative 2 in here, I would have a logarithm base 2 of negative 1. I cannot take the logarithm of negative 1.
True.
So, nope. All right, so this is all review of logarithm and exponents. Now we need to get back into systems of equations.
Is that fine?
So what are the 3 possible answers we can get when we have a system of equations?
That's a trick question. A positive and negative answer.
Nope.
So we don't want a negative
Oh,
in the exponent there, the
so
negative 1.
solutions-
Okay, I'm sorry. Sarah had asked a question here.
I
What does this mean right here? What this means is I want to take 2 to some power in order to get a negative 1. There's no number I can put on here to get a negative result.
Okay.
Put on it.
Yeah.
This is not the same thing as saying the logarithm is equal to negative 1.
Okay.
It is possible to have a negative 1 as a result of a logarithm, but not a negative 1. Yes, Tori, the 3 possible answers?
Infinite solutions, no solutions, and 1, 2.
So we can have infinite solutions, we can have no solutions, and we can have 1 solution. If we have infinite solutions, then we're going to get some answer that's going to look like this. 0 equals 0. We have no solutions, so I have something like 6 equals 7. Infinite solution will get something that's always true. If it's no solution, we'll get something that is never true. Those are the possibilities. Otherwise, we don't actually get a solution, which is good. Now, this process then, we have 2 possible methods of solving systems of equations. What would be those 2 possible methods?
Substitution and elimination.
Substitution and elimination. Which one is better? Do
Depends on the equation.
Depends on the situation. So we have to look at our situation to see which one we want to use. Now, having this in mind, we think about what happens if I have 3 variables. Because it's possible for me to have more than 2 variables. I can have 3 variables. And when that happens, there's a lot that is the same when we have a situation with 3 variables. And I mean, when you think about it, if I have something like this, 2x plus 3y plus 4z is going to be, and 3x plus 4y plus z is equal to 1. And I have x plus y plus 3z is equal to 13. Okay. So here I have 3 variables. And just like I mentioned earlier, when the United States was using this in World War II, you would have 20 maybe different variables of different things that you wanted to happen, and you would say, okay, I want all these things to happen all at the same time. And instead of using equations here, you would have inequalities. So it would be a different kind of a problem. But we're just looking at this as being an equation. And so we're saying, well, there's multiple things going on here, and we want to be able to solve this system now with 3 variables. What does that actually mean? Well, what did it mean when we had 2 variables?
You had the 3 possible answers. I mean, when you have 2 variables, you either have the solution that you're looking for is one of the 3.
Right. Okay. What does it mean to have one solution?
It means in a system of equation that one solution, they all intersect.
Okay, I don't want a geometrical understanding. I want the algebraic understanding.
One possibility?
One possibility where all 3 are the same, or all 3 come to the same answer.
That's the
You're getting close, you're getting close,
I
you're
can
getting
feel
close, and you might even know what the answer is, but the answer actually is that when you put the numbers into all of the equations, they come out to be true.
Okay.
So that when you put in the numbers here for x, y, and z, in the first situation, it will be 18. It will be equal to 1. It will be equal to 13.
It will work for the 3 of them.
It will work for all 3 of them. It will make all 3 of them true all at the same time. Okay? So that's what that's going to be like. Now, what does that actually look like, you might ask? I'm pretty sure that we can do this. Oh, no. Okay, so if we type 2x plus 3y is equal to 18. Okay? If you take a look at this right here, you can see that if I were looking down from the top with no z variable here, 2x plus 3y equals 18 would be a line. We know that. But then if I go into 3 dimensions, 2x plus 3y is equal to 18. That becomes a plane, 2-dimensional shape. Okay. Well, what if I put in plus 4z? It actually is, again, a plane. So in the same sense that when you have a flat surface and you have two variables, you draw a line, that line is just one dimension, okay, on a two-dimensional surface. This, when you have three dimensions and you have something like this, it becomes a two-dimensional thing. So this thing here, 2x plus 3y plus 4z is a flat plane. Okay. What happens if I do 3x plus 4y? 3x plus 4y plus z is equal to 1. That is another plane. Okay. And let's change that color here. Like I said, let's change that color. Color red. Okay, so you can see we have two planes. They will intersect in a straight line. Okay, so if I have one flat surface and another flat surface, and I put them together, they might intersect in a straight line. Okay, that would be like two lines intersecting in a point, right? You can see that here. Okay, but I have three of them. So I put in x plus y plus 3z is equal to 13. Now I have another one, and we'll change the settings on this one. Fuchsia. So, what happened here? Well, I should zoom out probably. So you see how I have these three planes that all cross, but then they actually cross at one single point.
Looks like I'm crossing a lot of places.
Well, see, each set of planes, the purple one and the blue one, they cross in one line. The red one and the purple one, they cross in one line. So they have a lot of things in common between each pair. But as you can see here, when you look down that little thing right there, it becomes a triangle, but it gets smaller and smaller until it gets to an actual point. So you can see the triangle on this end, but you can see it kind of getting smaller until it gets to a point right there. Okay? And that point happens to be -4, 2, and 5. -4, 2, right there. So that point is the intersection of those three flat surfaces. Now, again, you don't have to think about the geometry of this in order to understand what's happening, but I think it's helpful that what you're doing here is that you have these three flat surfaces and they intersect at one point. And that point, if I put in the coordinates of that point, it will make all three of these things true at the same time. Okay, so this is what we're doing, moving it up into 3 dimensions. And certainly, according to algebra, there's no reason why it should stop at 3. In algebra, we can put as many ones as we want to in here. As long as we can, as many variables. We can go x, y, z, w, u, s, t, j. We could, I mean, there's an infinite possibility, right? As long as we can find some set of coordinates or numbers that we can put in all the variables that make all of the things true, it'll work.
Mr. Flores, is it -4 and 2.5?
No, -4, comma, 2, comma, 5.
X,
How's it
Y, and
possible?
Z.
Oh, there's a Z, okay.
So in this particular example, if one doesn't say you don't get an answer, does that mean that this system has no solution?
That's correct. So we have, however, no solution, right? We could also have infinite solution, where when they all three come together, they come together in a line instead of in a point. That's also possible. So yes, and they could be parallel, right, in such a way that they don't have a point of intersection. And certainly we can make that happen here. It would not be hard if we just made this into.
So Z crosses Y and X in the middle.
Okay, right.
The red one is Z, right?
Okay. We have three different equations. This one is this blue thing. The second one is the red thing. The third one is the purple thing. Okay. What I have here, I'm pretty sure that X is the red line, the Y is the green line, and the Z is the blue line. So these things, these are my axes. These are my X, Y, and Z coordinates right here. So Sarah, does that make sense what I just said?
Yeah, I've never seen a
Okay,
Z
can I take a
before.
picture of
I'm used
that?
only to Y
Sure.
and X,
Yeah.
but I can see Z has taken over Y's place. Because Y is always the vertical one.
Well,
X is the horizontal. That's how we.
yeah, but here, remember these are in 3 dimensions. So that, I mean, if I wanted to, I could just flip this around and have Z or Y be the vertical one, or I could have X be the vertical one. It doesn't matter. Normally, we think about X and Y being flat and Z going up. Like
Really?
this.
I learn something new every day.
Yeah, all right, I hope so. All right, so this is what we're doing. We're doing 3-dimensional situations, and we're wanting to find the numbers that are going to make this work, okay? And certainly, as you can see here, if I were to do these graphically, I could make a graph, and then I could look for that point and hopefully find it, right? That would work. And I can do things that are much more complicated than this. I don't have to limit myself to just flat surfaces. For example, if I were to have, let's see if I can just clear this off. Don't say that. So if I were to do something like Z is equal to X squared plus 3 y squared. I would have this thing. It's a 3-dimensional shape. It's actually called a paraboloid. It looks like a parabola, but it's in 3 dimensions. And then if I would have something like,
Is that how they do 3D printing?
well, I mean, 3D printing, all you do is you have, like, depends on what you're using, but if like you have plastic, then you just put down a layer of plastic, move up a little bit, and put down another layer of plastic. Move up a little bit, put down another layer of plastic. So you don't have to make any kind of shape like this. You could have, you know, like a table. You can certainly do 3D printing on anything you can see in this room, right? All you have to do is you have to make the bottom of it, and then you go up a level, make the next layer, and then keep going up, and then just layer by layer, you just stack them up until you make it big.
Are you talking about or for Tori's question, maybe she's talking about the programming. So like when you actually set it up in the
Right.
program, trying to build.
Right, you'd have to
Y,
have
Z.
commands to do X, Y, and Z. Yes,
Right.
that's correct. So this is kind of fun.
What the heck?
This is a saddle. Oh, I should probably multiply this out.
Oh, there we go.
Let's see a little better. So yeah, this is a saddle. It looks like an upside down parabola this direction, but it looks like a regular parabola this direction. And so then you have a saddle point right there in the middle. So yeah, and then when you do calculus, you do this stuff. Calc 3, actually. No, Calc 2. So yeah, 3D stuff is fun. But my professor in graduate school, he said something like, once you get up to 7 dimensions, it becomes really hard to visualize in your head. And I was like, yeah, but he was so smart. It was great. But anyway, what we're working on, right,
Just something simpler.
is something simpler. We want to figure out the answers here. We want to find what X, Y, and Z are supposed to be in the situation. And we have to have a strategy, okay? If you just start combining things to see what happens, you'll be there all day long, and it won't get you anywhere. You have to think about what you're doing. You have to have a strategy. So what we're going to do is we're going to, first of all, start by talking about elimination. We're going to find a variable to eliminate twice. We're going to eliminate a variable, one variable, we're going to decide which one it is, and we're going to use a combination of equations. We're going to eliminate it in one equation and then eliminate it in another equation. So when you look at this right here and you say, well, how would that work? What would be the best thing to do? We could do any of them. Let's just do X, right? So I want to eliminate X. And this is how I do it. I number my equations. 1, 2, 3. And I circle them. And then what I'm going to do is I'm going to write down what my plan is, right? So what should be my plan? What should I do first?
Do an elimination of 1 and 2 first, and then
1 and 2 doesn't make sense because I want to use something that's easy,
Okay.
like
The
X
last one.
that has no
3.
coefficient.
Yeah.
So 2 and 3, or maybe even 1
Okay,
and
I'm
3?
going to have to use some equation, and I'm going to have to multiply it by some number so that the coefficients will be opposite. Just like with regular elimination, that's what I want to do, right? I want to get like a 5 and a -5 so that I can eliminate. I have to do that. I have to use all 3 of these. I have to decide which one to use on the other 2.
Use equation number 3 to eliminate X on equation number 1.
Okay, I'm going to use equation number 3, and I'm going to make it eliminate X in equation number 1. How do I do that?
Put the whole thing in -2.
Okay, so I'm going to write down -2 times equation 3 plus equation 1. So I'm going to take a -2 times that entire equation, and then I'm going to add those things to equation number 1. And I'm writing this down so I know what I'm doing, all right? I could do it mentally, but that would be a bad idea because then I wouldn't know exactly what I'm doing and I'd lose track. So this is what I'm going to do. So I have -2x plus -2y plus -6z is equal to -26. Equation number 1 is 2x plus 3y plus 4z is equal to 2. Now I'm going to add these equations together, and what do I get?
Y minus 2z negative 8.
Negative 8. I eliminated the x one time. I now need to eliminate the x again. So I used equation 3 to eliminate it for 1. What am I going to do next? I'm going to use equation 3 on equation 2. So it's negative 3 times equation 3 plus equation 1. So this is negative 3x plus negative 3y plus negative 9z is equal to negative 9. 3x plus 4y plus z is equal to 1. You thought you had problems before signs.
Yeah.
If you get any of these signs wrong, everything's wrong.
I know.
All the way through. And you have to start over if you get any of the signs wrong. And these problems take 10 minutes.
So are you gonna give us 10 minutes?
Sure, you can have all the time you want. Except I'm going to do it for you. Maybe. So this then is y minus 8z is equal to negative 38. And I certainly expect to make some errors while I do this. So what happened?
So we eliminated the x, and we have two equations that now have two variables.
That's correct. And so now I'm going to eliminate
Again,
what I have. Now, if I'm really crazy, I would maybe call this equation number 4 and equation number 5. Keep track of what I have, okay? And then I'm going to take, maybe I'm going to take negative 1 times equation 4 plus equation 4. So this is negative y plus 2z is equal to 8.
negative 6z equals negative 30 divided by negative 6.
Z is equal to 5. So that perennial question, am I done?
No.
No. Generally, when the teacher ever says, am I done, a lot of times the answer is no. All right? What do I need to do then?
Take z and put it back into at least one of those equations.
Okay, I'm going to want to put my z back into either equation 4 or equation 5.
Okay.
Because I want to find out what y is. I don't want to have to worry about x currently. So when I do that, put it in equation 4, I get y minus 10 is equal to negative 8. Y is equal to 2. Now what?
Stick both into equation 3.
Okay, I go back to equation 3, x plus 2 plus 15 is equal to 13. X is equal to negative 4. That's my answer.
So when we went to 5, did we take the result of that one and we subtracted the result of the first one, right? That's what we're doing right there.
Okay, right here,
We are
I'm
subtracting.
doing negative 1 times equation 4 plus equation 5. So here's negative 1 of equation 4. And then I'm adding it to equation 4.
So,
And yes, it is possible that you can, when you say, this is what I'm going to do, you then show that that's what you did right here. And this is what I'm going to do, that's what I did right here. This is what I'm going to do, I did it right there. So it's not just knowing what you do, It's keeping track of when you do it and writing those things down, because you have to keep everything together. And if you make a mistake, you have to be able to fix it. And it's nice if you can fix it going backwards. Whatever needs to be fixed.
Answer without positive date. I think once you have the equations numbered as you go along, it becomes more easier.
Yeah. Okay.
And now, my second method?
Okay, well, if we have some variable that is missing, then that can make things easier for us to do. So let's just say, as an example, I have something that looks like this. X plus 2y minus z is 1. Two x minus y plus z is equal to 3. And x plus z is equal to 3. So, what do I want here? I want to find a variable to eliminate. But in this equation number 3, the y variable has already been eliminated. So it will save me a little bit of work if I, from here and here, if I eliminate y, I don't have to eliminate it again. It's already been eliminated here. So when I look at this, then it's indicating to me I should eliminate y from the other equation. Now, it's not the only thing I could do, but that's what I'm going to do. So then, how am I going to eliminate y from the first two equations?
Multiply the second one by -2. Well, 2.
By just positive 2. If I take 2 times second equation plus the first equation, that will eliminate what I have. So, we're going to do that here. This is a 4x minus 2y plus 2z is equal to 6. This is x plus 2y minus z is equal to 1. So what do I get? Negative 2, or sorry, positive 2, negative 1, 1 z, positive z. Okay, so then what should I do next?
And you should.
What I'm going to do is I'm going to call this equation 4. Another equation. And what I can do is take negative 1 So what happens after I find out that x is equal to 1?
Equation 4.
Yep, you put that back into equation 4.
Okay, so then I put z is equal to 2. Then what?
Then you take that and you put it back into equation 3.
No.
Either 1 or 2.
Only 1 or
I'm
2, because
sorry,
I have to
one
find
or
out
two.
y is, I need to have a y variable. Okay, so if I put it back into equation 1, then that would be 1 plus 4 minus, wrong, 1 plus 2y minus 2 is equal to 1. 2y minus 1 is equal to 1. 2y is equal to 2, y is equal to 1. Yay. Yeah.
So do we keep on plugging them?
Back in.
Which equation? How do we choose the easiest one, the simplest one?
Yeah, I just pick whatever one works best, and sometimes it doesn't matter, so we just. Yeah. Now, we could have, however, solved this by using substitution instead.
That's what I would have done.
How would you have done that, Tori?
I would have, on the third equation, x plus equals 2, I would have set x equal to 3 minus z.
Okay, so then if we solve for x and get x is equal to 3 minus z, then
And stick that in the first equation.
if we put that into the first equation, we would have 3 minus z plus 2y minus z is equal to 1.
So we have 3 plus 2y minus 2z. And you subtract 3, 2y minus 2z. And then you would actually put a variable on one side and then stick that into the other equation, right? So you have-
Probably the best option here, well, that would be possible. That would take a little bit of thinking, right? What variable would we want to solve for?
I don't know, like probably y.
Yes, if we solve for y, then we would have y in terms of z. We would have x in terms of z. And then we could put them back in and just have one variable. That's possible. Another option would be to take that x is equal to 3 minus z and put that into the second equation.
Oh,
This was in 1. If I put it in 2, I would have 2 times 3 minus z minus y plus z is equal to 3, which would give me 6 minus 2z minus y plus z is equal to 3, which would give me negative y plus negative z is equal to negative 3. Once again, I have two equations with two unknowns. I could then use elimination between them. Or I could use substitution. Generally speaking, substitution takes longer.
Yeah,
Requires more
yeah,
algebra. Elimination does what we say, which is eliminate. And if you eliminate, elimination is good because then you have less things to worry about when you eliminate. But it is possible to use substitution. Now, could we have solved for x in this first equation?
Yes,
Sure we could. And then what would we do?
substitute.
We could substitute in here, and then we would have just y and z based on this. And then we could take this and put it in here, and we'd have y and z in here. And then we would have two equations in y and z, and we could do whatever we want. So it's nice if we can solve for x here, because then it's just x with z, and then we put it back in. But it's all a matter of choice. It's all a matter of finding the easiest way to do it. If we did solve for x here, that would be kind of a complicated thing. And if we put it into here, we'd have a lot of algebra. But it would ultimately come up to the same.
So over there, 2y minus 2z equals -2. That's it, it's done?
No. I mean, this is done in the sense that we've eliminated the x variable, and all we have is y and z.
Yeah, but still we don't have an answer, just like we got here,
Right.
we used elimination, we got our z, what number it comes, like, it's not clear though.
Yeah, this is not done because we don't have an answer.
Yeah.
This is also not done because we don't have an answer.
That's
But
like,
then we would have to put these together somehow. But we're not going to worry about that.
okay.
So that would be quite the problem. Now, could I have solved for x in the second equation? Well, I certainly could, but I'd have to have fractions. And then I'd have fractions everywhere. So I could have x is equal to 3 plus y minus z divided by 2. And then take that and put that in all the other equations. So it's not that I can't do stuff, it's just what's the best possible thing, right? So then I have to go through and figure out.
I'll rather mark my equations with numbers and deal with those.
Yeah. Well, good luck. So, yeah, we're 5 minutes over time, but that's
So
okay.
we keep on adding, that's the point though. Equation with equation, we keep on adding and adding, there's no subtraction.
Well,
Or it depends.
we are multiplying by a negative number and then adding,
Adding, yeah,
just to make it easier on our.
okay.
Certainly we could subtract. All right. And substantially, we only have one more thing to talk about.
Tomorrow,
No, I'm sorry, 2 more things. Three variable applications, and then matrices and determinants. Woo.